Hello everyone, welcome to today's class. We'll be starting a new topic, determinant. So this chapter is just an extension of matrix and moreover the application of matrix now. So determinant is basically a value of a matrix. Now how that value is calculated, we'll see. Okay. And remember that determinant is defined only for square matrix, means for any matrix that's not square will not define its determinant. Okay. So let's start. Let's say your A matrix is ABCD. Okay. 2 cross 2 matrix. In that scenario, how do you get the determinant of A? It is written by determinant of A, sometimes written as delta also. Okay. Delta also represents determinant, sometimes written mod A also. Okay. Determinant of A. All these are symbolic notations for determinant. Okay. We do calculate this. How do we calculate? Multiply this AD minus multiply this BC. Okay. First forward diagonal, then backward diagonal. AD minus BC. Okay. That's your determinant A. I'll rewrite this. Determinant of A or delta or mod A. Okay. So for 2 cross 2, all we have to do is cross multiply and subtract. Let's look at one question. So we have to calculate this determinant. So delta is equal to multiply 2 into minus 1 minus 2 minus 5 into 4, you'll get minus 20. So you'll get plus 18. Okay. It's very simple for 2 cross 2. Next is don't always get determinant with numbers. You can get with trig also, variables also. Okay. Like for this question. This time it's given cos theta sin theta. So again multiply. So determinant cos square theta minus sine into sine minus sine is there. So plus sine square theta it will become negative of negative. What is cos square plus sine square? That's 1. For this one again you have to multiply, but you can see this expression, it's complicated. Okay. So we'll not directly multiply this. What I can see here is a property. Multiply this, then multiply this. Okay. So in order to get the delta, I have to multiply x plus 1 into x square minus x plus 1 minus this one is x plus 1 x minus 1. I think the second expression you can easily identify. This is a plus b, a minus b. And what is happening here is, I'll write a plus b, a square minus ab plus b square. If you see this, you know which property is this. This is a cube plus b cube. Okay, so x cube plus 1. So I don't have to completely multiply this. If you want, you can multiply, but with the property this becomes simple. Minus this becomes x square minus 1. So basically x cube minus x square. No, minus of minus 1 plus 2. All right. So with the property it becomes simple. Otherwise we would have to multiply. Okay. All right. Next is your another question based on this 2 cross 2. Let's get over with this 2 cross 2 concept. Okay. This time he's saying two determinants are equal. Remember this, if only it was curved bracket type thing, then only it's matrix. Otherwise straight lines, that means he's saying it is determinant. Okay, so if it is written A, B, C, D, that means he's saying determinant of A. Okay, this represents matrix, that represents determinant. The only difference is with the notation. There it is a bracket, there it is a straight line, kind of like mod. So this time he's saying the matrix is not equal, the determinants are equal. So let's solve the left determinant. So 2 minus 20 is equal to 2x square minus 24. Solve it accordingly. Minus 18 plus 24 is equal to 2x square. So 6 is equal to 2x square. X square is 3, x is plus minus root 3. Okay. 2x square, 24, 2 minus 20, minus 18 plus. Okay, fine. The answer is coming in fraction square root, but that is okay. Root 3, 6 minus 24 minus 18. That is also coming. So verified also. Okay. Fine. We are done with now 2 cross 2. Let's go for 3 cross 3 now. Okay. You will be covering 2 cross 2 and 3 cross 3. That's it. We can extend the concept for 4 cross 4 also, but it will be very lengthy. Okay. All right. Let's say we have to calculate determinant of this. So for 3 cross 3, I'm not writing any sort of a formula. I'll just extend the idea. Okay. All right. Determinant of 3 cross 3. Let's look at with the help of this example. So in order to open a determinant of 3 cross 3, first get comfortable with determinant of 2 cross 2 and just extend the idea. There are multiple ways to open the determinant. You can open it about any row or any column. I'll extend the meaning of it. First, understand this symbolic notation: plus minus plus minus plus minus plus, sorry, minus plus minus plus minus plus. Okay. Now you have to use this. Let's say we are expanding. There are multiple ways to solve it, I told you. So expanding about, let's say, row 1. Okay, row 1 means this. We are going to expand about this. So first of all, we'll use this. So we'll write the first element. So for first row, this is the symbols we have to use: plus minus plus, plus minus plus. Okay, so we'll write first element 3. Okay, 3. Okay, with positive sign because it's positive written. Then leave the row and column. Okay, the row and the column of this element. You will see a 2 cross 2 is left. That will be multiplied with 3. 2, 1, 1, 1. Okay. Then next element, that has to be opened with minus. So minus and then 8. Do the same thing. Leave 8. We are doing for opening for 8. So leave the column and the row of 8. So again you will see a 2 cross 2. minus 4 1 5 1. Okay. Lastly, same idea you have to do for last element, that's 1, so it has to be opened with positive sign, so positive 1. Leave the row and the column, you'll see a 2 cross 2 1, minus 4 2 5 1. You have to open the determinant. So basically we have converted a 3 cross 3 into 2 cross 2, and now you can pretty much solve this. So 3 into 2 minus 1 1, minus 8 into minus 4 minus 5 minus 9, plus 1 into minus 4 minus 10 minus 14. Okay, so 3 plus 72 minus 14. Okay, so 75 minus 14, that's 61. Okay, we expanded this about row 1. Now there is no constraint that we cannot solve this about row 2 or row 3. We'll get same answer while expanding. It's just that you have to use these signs, positive, negative, positive, whichever row you are expanding or whichever column also. I'll expand the same determinant about let's say column 3, 1 1 1 is there, so let's expand about column 3. Okay, all right, so same question, let's expand it about column 3 and let's see if we get the same answer or not. So column 3, this is C3, expanding about it. So for the last column also the symbolic notations are positive, negative, positive, negative, positive, negative, positive, negative, positive. So same thing, plus, minus, plus. So first let's open with this 1 into determinant of minus 4 2 5 1, then minus 1 into second one with a negative. We are expanding about this, so leave this row, leave this column. 3 8 5 1, then plus 1 again, determinant of this is plus 1. Leave the row, leave the column. 3 8 minus 4 2. Okay, so since the outer element was 1, so it was easier to, we don't have to literally multiply anything, just solve the determinants. So minus 4 minus 10 minus 14, negative of 3 minus 40 minus 37, plus 6 minus of minus plus 32, so sorry, 6 plus 32 38. So minus 14 plus 37 plus 38, so again minus 14 8 7 15, again 75 minus 14, again we got 61 as the answer, which I told you that no matter which row or which column you use to expand the determinant, it's pretty much the same. All right, now let's look at the application. Okay, application part. First one, suppose you have 3 points, x1 y1, x2 y2, x3 y3. Okay, and a triangle is created, of course, like this. You can get the area of this triangle using determinants. How can you get this? The area is equal to 1 by 2 determinant of, you can write 1 1 1 x1 x2 x3 y1 y2 y3. You can write row wise also, column wise also, your call. Okay, or 1 by 2 1 1 1 x1 x2 x3 y1 y2 y3. Okay, that will give you the area. And remember that area is a scalar quantity. Okay, so area cannot be negative. Okay, so if you get a negative answer, just apply another mod to make it positive. Okay, so area is always positive. Determinant can be negative as well as positive. Okay, whereas determinant can be positive, negative, okay, 0 also, but positive and negative mainly I'm talking about. So your answer can be positive or negative, just apply mod on it, you'll get a positive answer, that will be your final answer. Okay, this is the first application. Second one, suppose you have 2 points, x1, y1, x2, y2, and you want to write the equation of a straight line passing through it. Okay. So equation can also be written using this determinant. So equation of straight line is given by determinant of 1, 1, 1, x, x1, x2, y, y1, y2, like this, is equal to 0. That will give you the equation of straight line. Or you can write like 1, 1, 1, x, x1, x2, y, y1, y2. Remember that y1, y2 will be some coordinates, so that value you'll know. X and y will be x and y, because your equation will be consisting of x and y. Na? Equation of straight line is ax plus by plus c equal to 0. Okay. This is the property of determinant, that you can write it row wise or column wise, it won't make a difference. Basically this is nothing but a transpose of it. So transpose determinant is all same. We'll study this in the properties when we'll see this. Okay. All right, so let's look at one question. I used the same one to calculate the determinant also. That will help you. Look at this question. 3, 8, minus 4, 2, 5, 1. Okay. So if I want to find the area of it, what I'll do is area is equal to 1 by 2 determinant of first of all 1, 1, 1, 3, 8, minus 4, sorry, x coordinate na, so 3 minus 4, 5, and then y coordinate 8, 2, 1. Okay. x1, y1, x2, y2, x3, y3. Open the determinant. Okay. This is pretty much the same determinant that we almost opened here. Okay, 3, 8, 1, 4, minus 4, 2, 1, 5, 1, 1. Okay. 3, 8, 1, minus 4, 2, 1, 5, 1, 1. So the order is different again. But once you open it, you'll get the value again, let's say 68. Or let's say you got the value as minus 68. Okay, I'm not solving this. I'm just saying, let's say you got minus 68. So that's 1 by 2 into minus 6. No, 61 was there, no? Determinant we solved. 61. So let's say you got minus 61 for this, hypothetically. Let's say. You have to apply a mod because answer is coming negative. So you will apply a mod by yourself to make sure you get the correct answer. So answer is 61 by 2 square units. Okay. Just to make you understand that. Okay. Now one more concept is we'll use one concept, we'll see about that. First is saying there are 2 points, you have to, using determinant, you have to find equation of line first of all. So let's find first that. So equation of line, x1 y1 x2 y2. For equation of line is 1 1 1 1, sorry, yeah, x coordinate, 1 1 1, then x coordinate 1 sorry, x 1 0, okay, then y 3 0, and we have to open the determinant. Now while opening the determinant, sometimes you have to see for which row or for which column it is easier. See, if I expand about this column, it has 2 zeros in it, so it makes my determinant very simple to open. All I have to do is use the signs, positive, negative, positive, and then expand 1 into, if I leave the row and the column, I'll get x1 y3. Yeah, this one equals to 0. That's the way it will be. And the remaining thing, minus 0 plus 0 into anything that you solve, effectively 0 into anything is 0, no? So why we are even bothering with writing that? Don't even write that. Okay, and it is equal to already 0. So let's cross multiply. So you get 3x minus y equal to 0. So that's your equation of straight line. That's your answer. Okay. Now he's saying find k if D is a point such that area of the triangle ABD is 3 square units. Okay. So now you have 3 points. One is A, another one is B, another one is T. Coordinate of D is k comma 0. A is 1 comma 3, B is 0 0. 1 comma 3, B is 0 0. That means B is origin. He is saying that the area of this triangle is 3. Okay. So what is the formula of area? Area is equal to 1 by 2 determinant of 1 1 1. Okay. Then coordinates, x is 0, y x1 is 0. Let's say this is x1, 0 1 k, 0 1 k, y is 0 3 0, 0 3 0. Okay. Now the point is, should I write directly this is equal to 3? Because see, I told you that determinant can be positive and negative. The point is area is coming 3. That means determinant could have been plus 3 or minus 3. Means this value could have been plus or minus 3. Okay. So that means we have to solve for this for 2 times. For one time we have to solve it for plus 3. One time we have to solve for minus 3. So let's open it, and again I'm expanding about this, because see, 2 zeros, it makes me open about this because it makes the calculation simple effectively. So 1 by 2 determinant about this. So 1 into, just solve this, 1 into 3k minus 0, so 3k, and 0 into something something, again not being bothered about that, positive negative positive. So plus 1 into this, 0 into something, 0 into something is equal to plus minus 3. Okay. So basically 3k by 2 you have to solve it for plus 3, and 3k by 2 you have to solve for minus 3. So k is coming 2, or k is here coming minus 2. So both are correct answer. Okay. For this, both plus and minus k can be the answer, plus 2 or minus 2. Okay. Fine. Now that you have learned the application part, let's move to the next point. I'll take one example to explain the whole concept of the next question. Okay, next question, or even next question. That's the next question. But the topic is minors and cofactors. Okay. Interestingly, we have already done that. It's just that now we'll understand the determinant in much more depth. Okay. You already know minors and cofactor. It's just that I have to explain it, that which part that you have learned is your minor. So every element has a minor m11. See, first element, this is a11, so the minor of that will be called m11. Okay, I'll tell you how to calculate that. Similarly, for second element, we can calculate m12, we can calculate m13. Minors will be represented by m21, m22, m23, m31, m32, m33. So basically, how do we calculate minor? For first element, if you are calculating minor, leave the row, leave the column. You get a 2 cross 2 matrix. Solve the determinant of that. 0, 4, 5, minus 7. What is the determinant? 0 minus 20. So it is minus 20. Okay. Let's do it for any other value. Let's calculate for this m22. Okay, for this one. So leave the row, leave the column. You'll get a 2 cross 2 matrix. 2, 5, 1, minus 7. So in order to avoid mistake, better write one time. 2, 5, 1, minus 7. Now solve the determinant. Minus 14, minus 5, minus 19. Okay. So pretty much you can calculate minors for every single element. I'm not going to solve each and every minor. It's just that I'm trying to explain that you can calculate for anything. Let's say you want to calculate m33. Okay, let's take slightly complicated m32. So leave the column, leave the row. You get a 2 cross 2 element, m32. Okay, so 2, 6, 5, 4. Calculate the determinant. You'll get 8 minus 30, so minus 22. Okay, that gives you the idea. Okay, all right. Now that's your minor, capital M. Cofactors are represented by A. I know it should have been C, but it's the notation. They are usually represented by A. I do prefer C. So cofactor, let's say C11. We have already calculated M11, so I'm calculating C1. C1 is nothing but minus 1 raised to power 1 plus 1. Okay, M11. If you are calculating C11, just raise the power of minus 1 with the addition of the 1s. Okay, we have already done that. This is minus 1 raised to power 2, which is positive. So plus M11, which is plus of minus 20. So basically minus 20. Okay. Let's take, we calculated M22. Or let's take M32 first. Let's calculate C32, cofactor. Third column, third row, second column. Okay. So minus 1 raised to power 3 plus 2. Okay. Whatever you are writing here, just add them, raise the power of 1 with that. Okay, so C12, M32. So this is negative minus 1 raised to power odd. Okay, negative M32, that's minus 22. So that is plus 22. So I hope you get the idea how to calculate minors and cofactors now. We'll be doing this separately also, but this is just to give you an idea, because this particular part, calculating cofactor of all the elements, we'll be doing that in adjoint. Okay. All right. Now you know minors, yeah, now you know cofactors also. All right. Next, I think is adjoint. Yes, next topic is adjoint. All right, let's move to this next topic, adjoint of a matrix. I know we are studying determinants, but I told you that it is related with the matrix. So adjoint, one second. Of matrix. Again, adjoint will be calculated for 2 cross 2 as well as 3 cross 3. Okay. Let's see for 2 cross 2 first. Let's say A is your matrix. Okay. In order to avoid the confusion, because A represents your cofactors also, I'll take a matrix, let's say X matrix. Okay, and you have the elements A11, A12, A21, A22. Okay, then adjoint of that matrix, adjoint X, first of all it's a matrix, you have to understand that, is cofactors A11, A12, A21, A22 of this, and do the transpose of it. You calculate cofactors of this, arrange in a matrix, and then take a transpose of it. I know it sounds lengthy, but let's see what happens for ABCD. Suppose your matrix was X was ABCD. Okay. All right. Let's calculate A11. A11 means the first element, leave the first row, first column. So basically minus 1 raised to power 1 plus 1 into D. So that is D. Let's calculate A12. Okay. So A12 is minus 1 raised to power 1 plus 2. A21 minus 1 raised to power 2 plus 1. A22 minus 1 raised to power 2 plus 2. Okay. 1 we have already calculated. Let's see for A12. So 12 is this element, leave this, what do we get? C. So this is C. Minus 1 raised to power odd, so minus C. Okay. This one C, second row, first element, leave the row, leave the column. This time it will come B. So minus 1 raised to power 2 plus 1, again B. So minus B. And last one, this A22, leave the row, leave the column, A. Adjoint is A. Minus 1 raised to power even. So it is positive A. Let's arrange it in our matrix first of all. So if we arrange this in a matrix, adjoint of X, we get D minus C minus B, A. And what do we have to do? We have to do transpose of it. So row becomes column. So first row becomes first column, second row becomes second column. So finally your adjoint A, this is the whole working. Now what you have to remember, adjoint A is directly DA minus B minus C. How to remember this? Use this. Okay, this one is interchanged and this one. So for the first diagonal you interchange them. Okay. Not for this, for this. For the first diagonal you interchange them. So DA will become AD. So just interchange. For the second diagonal you apply a negative sign. Put negative sign. So for 2 cross 2, you shouldn't take more than like 20-30 seconds to write down the adjoint of any matrix. Interchange the first diagonal, put the negative sign with the second diagonal. That's it. That's a direct approach. Like, do it for this question. Find the adjoint of A. For A is 2, 3, 1, 4. So adjoint of this matrix A is, interchange these. So 4, 2. Apply the negative sign with the other one. 3 and 1 will become -3, -1. As simple as that. Okay, so don't waste your time in calculating the adjoint. It's a lengthy process. Okay. All right. This is done. This is done. Finally, now let's talk about uh, 3 cross 3. Okay. Let's see. Let's see how to calculate the adjoint of a 3 cross 3 matrix. Okay. So this is your matrix. Now for 3 cross 3, I'll teach you. Of course, you can go and literally calculate every single cofactor, then arrange them, then calculate the transpose, or learn this short way. Okay. So shortcut for 3 cross 3 adjoint. Okay. Let's see. What you do is, let's write the A matrix first. 1, 1, 1, 3, 3, 4, 3, 3, 4. Copy the first column, copy the second column. So what I've done is copied it. So 1, 1, 1 here, 3, 4, 3 here. After that, copy first row and second row. So 1, 3, 3, 1, 3, 1, 4, 3, 1, 4. Okay. Now that you have done that, leave the first row, first column and first row. Focus on only this. A 4 cross 4, you can see. All right. One second. Let's get everything aligned properly. So we are leaving the first row and first column, and you can see a 4 cross 4. All right. Now focus on this box. I'm highlighting it with red color. Let's make that black. Okay, you can see a 2 cross 2 here. That's your A11 directly. Okay. So I will write adjoint directly now. Adjoint is equal to, solve this, 16 minus 9, so you get 7. Okay, that's your A11 directly. Next, this one, move the square to the next one, just one block on the right. So 3, 1, 4, 1. So solve the determinant. 3 minus 4 minus 1. That's your A12. Okay. Move it to the next 1 4 1 3, so 3 minus 4, again minus 1. Okay, so a1 1 1 2 1 3 complete. Now shift this, we started from here, shift it downward one row, and same process you repeat it. 9 minus 12, you'll get minus 3. Okay. Next, move it here. 4 minus 3, 1. Next, 3 minus 3, so 0. All done for second row. Now move it, we started from here, we shifted down for second row, we shifted down one more time for third row. Solve it again. 9 minus 12, minus 3. 3 1 3 1, so 3 minus 3 is 0. Last 1 3 1 4, so 4 minus 3, again 1. But don't forget to transpose, because this gives you only adjoint cofactors. Okay, so you have to do transpose of this. Okay. So the transpose is 7 minus 1 minus 1, row becomes column, second row becomes second column, minus 3 1 0, third row becomes third column, minus 3 0 1. That's your adjoint directly. You don't have to literally calculate a1 1 1 2 by like doing this. Forget about that, because and usually there is a tendency to make mistake also. It's a lengthy process, it's very peculiar. You have to be very careful with the positive, negative and everything. Right now there is no negative sign for this question. Suppose there is negative sign also involved in this, so that will make this much more complicated. Okay, so 7 minus 1 minus 1, minus 3 1 0, and minus 3 0 1. Yeah, that's correct. Okay. This is how you calculate the adjoint of 3 cross 3. All right, so far we have learned the adjoints. Now last thing I think I have to teach you is how to calculate the inverse. So I'll use the same example so that we don't have to calculate the adjoint one more time. Okay, same matrix I'll take, and I'll teach you how to calculate inverse. First of all, I'll have to tell you what is inverse of a matrix. Okay. First of all, what is an inverse? If suppose you multiply A with B and it resulted in I. Okay, AB is equal to I, or you B multiplied by A, you pre-multiply or post-multiply, it doesn't matter whether you do AB or BA. In that scenario, we'll say B is called A inverse of A matrix. Inverse of A. So basically it's a matrix which we multiply with a given matrix and the result is an identity matrix. Okay. All right. Now comes the formula A inverse. Why was this adjoint important? Because it helps us to calculate the inverse upon determinant of A. This is the formula for inverse. So all you have to do is calculate the adjoint and divide it by its determinants. Slightly lengthy process. For 2 cross 2 it will be easy. For 3 cross 3 it will be lengthy. Okay. Let's take one example for a 2 cross 2. Let's calculate for a 2 cross 2, then we'll calculate for 3 cross 3. One more thing, remember that if determinant of A is 0, then this denominator becomes 0 and this things become not defined, then A inverse doesn't exist. So in order for any inverse of a matrix to exist, the determinant has to be non-zero. Okay. All right. So for this is our matrix. The question is find A inverse. Okay. So let's calculate the determinant first. Okay, so 6 minus of minus plus 8. Okay. So basically 40. Now let's calculate adjoint of A. Now adjoint is interchange these, so 3, 2, and apply negative sign with the other diagonal. So minus 2 becomes plus 2, 4 becomes minus 4. That's the adjoint. So A inverse is equal to adjoint A divided by determinant of A. So 1 by 14 of 3, 2, minus 4, 2. So how do we divide or multiply by this scalar 1 by 14? Multiply each factor by 1 by 14. So 3 by 14, 2 by 14, minus 4 by 14, 2 by 14. Okay. All right. For 3 cross 3, let's take the same example. Since we have already calculated the inverse, adjoint, I mean. So still the same question, find A inverse. Okay, so for that we need determinant of A. So let's expand it about this 1, 1, 1, so that we don't have to worry about the multiplication factor. So positive, negative, positive, this is the sign. Okay. First row or first column is positive, negative, positive. Second is reverse, negative, positive, negative. Third is always same, positive, negative, positive. So 1 into, now I'm doing direct, 4, 16 minus 9, so 7. Okay, so 1 into 7 minus 1 into, leave this, 12 minus 9, 3. Okay, then last one into plus 1 into 9 minus 12 minus 3. So 7 minus 6. Wow, it's coming 1. Good enough. Okay. Even if it was coming some value, we have to divide by each element by that number. Won't make much of a difference anyway. Okay, so let me check. 1 into 16 minus 9, 7, minus 1 into 12 minus 9, 3, then 1 into this, yeah. And finally your adjoint A, sorry, adjoint we have already calculated, so just copy that. Okay. Adjoint is this. Finally A inverse is adjoint A upon determinant of A, which is 1. So basically your adjoint itself is the inverse of the matrix. 7 minus 1 minus 1 minus 3 minus 3, 1 0 0 1. Okay. All right. Now that pretty much summarizes how to calculate it. Okay. The properties are much more important part of it. So we'll study about the properties of determinant, properties of adjoint, properties of inverse, very much in detail. Okay. So that part will be covered in the next video. And that's it for this class. Okay. See you in the next class. Good day, everyone.